Hey everyone, this is Math for Teachers, our final team presentation. My name is Robin Surf.
I'm Maria Segura Bolaños.
And I'm Patricia Montgomery.
And this is our final presentation. Hope you guys enjoy it.
All right, Robin, how do you complete the 3 empty circles in figure 2?
Okay, so you could possibly use the guess and check method. This method is used to simply guess a number and check to see if it is right, but you can actually work out a small series of equations to answer this puzzle. So let's go ahead and look at the first step. The first step is to notice that 6 plus question mark equals 21. So the answer would be 15. Then you can notice that 15 plus what equals 19. The answer would be 4. The last equation is 4 plus what equals 11, and that answer would be 7.
Awesome.
Perfect. Nice.
Maria, sketch all possible figures which can be formed and find their perimeters.
Okay. Let's make some figures. These are kind of fun because it's kind of like using building blocks. So right here, first we have a 3 by 3 square, which equals out to 9 total blocks. But in order to count, then we have a little Tetris looking one. Then we have, these are all like Tetris figures to me. So we've got 4 different figures with different amounts of blocks, so it looks like, but let's see if the perimeters match or not. So to find your perimeter, basically what you're going to do is you're going to count the lines on the outside of each square. You're not going to count the inside lines, just the outside perimeter lines. So yeah, I like to make little tally marks to count to make sure I don't miss any of my lines. So we'll start here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one will have a perimeter of 12. So now we're going to do the same thing over here for our little orange figure. Again, we'll start at the top. I'm going to mark each of my lines. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And so that makes a perimeter of 20. Now we're going to do the same thing over here. I'm just going to zoom through it because it's kind of being slow for us today. So the same concept. The only thing is like right here in these corners, I would make sure and make your little tally mark because I sometimes will skip one thinking I already counted it and the corner pieces. So make sure you put your tally marks there. So the same thing, we counted all of our lines. We get a perimeter of 16. Now this one looks like it may be, I'm curious to see which one's going to be bigger. Because just because it looks like it has more blocks doesn't necessarily mean that it has a more amount of perimeter around it. So this one is actually going to match this one over here, even though it's a completely different shape. It actually has a perimeter of 16 as well. So it's always good to count your lines and don't just assume you know what the perimeter is going to be, but based on the design.
Very good.
Perfect.
Hey, Patricia, how do you calculate the perimeters of each of these figures?
So basically we're going to do what you just did with us. So the perimeter is just going to be all the sides added up, and it told us that they were all 1 for each side. So we're just going to go through and count those up and see what we got. So for the first one, we got 18 all the way around it. And then we got 16, 12, 14, and then 20.
Awesome. You see, I like that you did different figures because this looks like it's more than 16 to me compared to the other figure. So it's very good.
Yeah, I think so
like
too.
that.
Thank you.
Hey, Patricia, using the Venn diagram below, what elements belong to A?
So for set A, we're looking at that little middle circle piece, and that line on the top is going to say that we're going to use everything else in our Venn diagram except for that part. So all of those shapes that are inside the box are what we're going to do instead of what's in the middle. So
Okay,
those
so
are what we
not
got.
the circles. Okay,
Yes.
awesome. So that would be what's not in the circle with A. Got it. Okay.
So Robin, what would the Indo-Arabic to the Roman numeral MCML be?
Okay, so what would be the Indo-Arabic Roman numeral MCMLXVI? Well, let's go ahead and look at the chart. We can see that MCM will be equal to 1900. So the L represents 50. So from there, the answer is at least 1950 something. And the last part of the Roman numeral is XVI. So we need to take the 50 from the L and add 10 plus 5 plus 1. And that answer is equal to 66. So the complete answer is 1,966.
Okay. Good job. Way to break it down.
Perfect. Thank you.
Thanks.
Yeah.
All right.
So this
Maria,
is, go ahead.
will you go ahead and show us the Babylon numeration system?
Yes, ma'am. So here's the grid, basically your table of contents right here, your key. As you can see, this little, I tried to get this most similar figure I could without, because these aren't really accessible and I can't draw them very well. So this is going to be worth 10. That's our little triangle right here. And then we have our sideways triangle or open arrow, whatever you want to call it. Then we have this little figure that's kind of like an upside down triangle, which is a 1. So we've got 10 plus 10 plus 10 plus 10, which would be 40, plus 1, which is super simple. If you do 4 times 10 is 40, and then you have to bring your 1 down. Super easy. Your answer is 41. The Babylonian numeration system is actually one of the easier ones to follow because it's just simply adding the figures of what you see. So super easy. One of my favorites.
I like it.
Yeah, cool. Good job.
Thanks.
All right, Robin, can you use the divisibility test of numbers to complete the chart below?
Okay, so let's go ahead and look at the chart. And basically, they would like to know if any of the numbers in the top row are divisible by the numbers in the left column. And there are certain rules you can ask yourself to find the quick solution. So let's take a look at the first number in the list, which is number 2. Any number which ends in an even will be divisible by 2. So we can ask ourselves this question in going across the row. Does this number end in an even digit? So let's go ahead and look at number 2. Does the number end in an even digit? No, it does not. Number 3, are the sum of the digits in the number divisible by 3? No, it is not. Number 4, do the last 2 digits from a number divisible by 4? And no, it is not. Number 5, is the last digit a 5 or a 0? Yes, the last digit is a 5. Number 6, is the number divisible by both 2 and 3? No, it is not divisible by 2 or 3. Number 8, do the last 3 digits form a number divisible by 8? And no, it does not. Number 9, is the sum of the digits divisible by 9? No. Number 10, is the last digit a 0? No, it is not. And our last number 11 on our chart, when adding the digits with alternating the plus and the minus signs, negative sign, can the number be divided by 11? No, the sum of alternating is the sum of the digit rule.
Awesome.
Goodness.
That's a lot of work.
For a bunch of them.
All right, Maria, can you solve the problem below using the casting of nines process?
I can. So when you're using the casting of nines process, you're basically going to cast out the 9s that are in your problem. Cast them off the island is what I like to say, because you're getting rid of them and you're going to figure out if you check your answer. So we've got 416 plus 7,490 plus 69,844, which is going to equal, supposedly, we don't know for sure, 112,790. So in order to check our answer, what we're going to do is cast our 9s away. We're going to send them off the island. We're going to take that 9 away. We're going to take this 9 away. Now, in our answer, we actually have 3 numbers we're going to take away. We're going to take away the 2 and the 7 both because they both equal 9. And then we're also going to take away this 9 right here. Then the next step would be to break down each number and basically separate it out and then add the numbers together. So you've got 4 plus 1 plus 6 equals 11. We're going to break that down again to 1 plus 1, which is 2. Then you've got 7 plus 4 plus 0, which actually is going to equal 11, not 10. So we'll made a mistake there. And then we have 1 plus 1 equals 2. Then we've got 6 plus 8 plus 4 plus 4 is 22. And then we break that down further to 2 plus 2 equals 4. Then in our answer, the only numbers left are 1 and 1, so that equals 2. So now to check to make sure that our answer is right, the next step would be to add these numbers together. So we've got 2 plus 2 plus 4 equals 8. Now 8 and 2 right here are not the same. So that means this answer is wrong. That's not the right answer. In order for this answer to be correct, this number would have to match our number up here, and it does not. So the actual correct answer is 77,750. And then to check that, we'll break it back down just like we did above. So we got 7 plus 7 plus 7 plus 5 plus 0 is 26. Then we break that down even further to 2 plus 6, that's going to equal 8. Bam, our 8 matches our 8 up here, so that means this is the right answer.
Woohoo!
Awesome. I like how you showed your work.
Thank you.
Makes it easier to understand.
Yes.
All right, Patricia, how do you find the greatest common divisor of 9 and 18?
All right. So what we're going to do is we're going to find the factors of each of those numbers and see what they have in common. So for 9, our factors are going to be 1, 3, and 9. And then for 18, our factors are going to be 1, 2, 3, 6, 9, and 18. So the ones that they have in common are going to be 1, 3, and 9. And since we want the greatest common factor, where it's going to be 9 between the two.
Awesome.
That makes sense.
Huh.
All right, Maria, if the grid below has 50 total squares, what is the percent of shaded in squares?
Okay, so for this one, what we're going to do is we're going to add up our shaded in squares. So we're told we have 50 total squares completely in the grid. So for shaded in, we've got 6 here on each corner, and there's 4 corners, so that would be 6 times 4. Then we have 2 in the top, on the top, and 2 on the bottom, so that's 4 more squares. So we're going to do 6 times 4 plus another 4. That's going to give us 28 total shaded in squares. Now we're going to take our total amount of shaded squares and divide that by the total amount of squares we have. That's going to give us a 0.56 as our answer. Then we're going to take that, we're going to multiply that by 100 to get our percentage, and that comes out, brings us to 56% for the answer.
Awesome.
Perfect.
Good.
Nice. All right, Robin, are you able to understand why the graph below has its shape?
Okay, so let's go ahead and look at this graph. This is the graph of what x divided by 2 looks like. So if you could actually say that for every 1 male born in the US, there are 2 females. That is why the line slopes at an angle. So if you notice on the x-axis, every time you move over 1 unit, the y-axis units will move up approximately 2 units. So you can see how for every 1 male, there are 2 females. The graph will actually slope upward in that direction.
Okay, I see that.
Nice. I like it.
All right,
Thank
Patricia, can you match the pieces below with their correct percentage?
All right. So it shows us in the problem that this yellow hexagon is a whole piece of 100%. So we want to see what percentage these two figures would be of that. So for the first one, we could tell that we could fit 2 of those inside of that yellow hexagon, which would be 100 divided by 2, which would give us 50%.
Okay.
So our trapezoid is 50% of our whole shape. And then for the rhombus, it looks like about 3 would probably fit. So if you divide 100 by 3, you would get 33.3% for our rhombus.
Okay.
Perfect.
Awesome, ladies.
Yes, yes.
All right.
Woo.
Thanks, guys. We've enjoyed it. It's been awesome. It's been fun.
Thank you for
Thank you,
joining
thank
us.
you.
All right.
Bye.